Hey, what's up guys? This is a second video for section 7.3, which is rational exponents. On the previous video, I showed you guys how to simplify when you have different roots with the different fractions as an exponent and also variables inside of a radical. So I'm going to show you guys one more that I think is very important for you guys to know, and is when you guys have one variable inside of the radical and the exponent might be a little bit different than the root. So let me show you guys what I'm talking about. So you guys see this radical, this expression here on the screen, and it is a third root. So we're looking for the third root of this expression here, and we have 24a to the 7th and b to the 2nd. Well, you guys will do the same thing as the previous video, where you guys break down the 24, the number, and I'm just going to do this right here. So we have 8 times 3. We know that 8 is 4 times 2 and 4 is 2 times 2. You guys will make groups of 3s in this case because we are looking for the third root. So I am going to look for those groups of 3s, and I can see I can have a group of 3 2's. So that number 2 is going to go outside of the radical. Now inside, we're going to have a number 3 because the 3 here doesn't have a group of 3's. And then we're going to look at the variables a to the 7th power and b squared. So first, let me write down the third root with the radical here. I'm going to put the number 2 outside, which is the group of 2's. We made 3 2's, so that's going to go outside. And then I'm going to start looking at the exponent of the variable. So the a has an exponent of 7. So I'm going to do the long division here. I'm going to divide 7 by 3. So 3 goes into 7 2 times. That's going to be 6. And the remainder is 1. So this number is how many a's you have inside of the radical, and this one tells you how many you guys have outside. So the a is going to have a squared because that's the number on top of the division here. So we have 2 outside and then 1 inside. Now remember that we do have the number 3 here, so I'm going to write that down first in the radical. So there's the 3, and then I'm going to put the a, and it's going to have an exponent of 1. We don't need that 1, so you don't need to write it, but let me go to the next variable here. B has an exponent of 2. So if you guys have an exponent, so let's say there's a 2 and you divide by 3, well, 3 does not go into 2. This exponent, it is smaller than the root. So when that happens, guys, you can't divide. We don't want decimals, so you guys are not going to divide this here because 3 doesn't go into 2. So what that means is you're going to keep the b squared inside of the radical. So here's another way to see it. If the variable inside of the radical has a smaller exponent than the root, the exponent is smaller, then you guys keep that variable with the same exponent inside of the radical. So my answer is right here. 2a squared times the third root of 3ab squared. So now we are going to move on and look at different roots that you guys need to simplify, and also something different which are kind of like new for you guys, and they are exponential equations. But first, let's go to the next slide. So we actually have a rational exponent in this slide. What you have to know is the exponent can have any fraction with a number on the top, numerator, and a number on the bottom. On the previous video, all the fractions I show you guys as an exponent had a 1 on the top on the numerator. Well, if you look at the example down here, we have 8 to the 2/3 power. Notice the exponent is a fraction, and this is not a 1, is something else. So this number on the top can be any number other than 1, and the bottom can be any number. You can also have negative exponents as fractions or negative fractions, but we're not going to do those in this section. We're going to do those later on. But let's go ahead and look at what the fraction means here. So when you guys have a base, a number, and the exponent is a fraction, the numerator will tell you guys how many times you're going to raise this number to that power. So for the example here, this 8 is going to be raised to the 2nd power. And the bottom is going to be the root that you're looking for. So if you have a 2, you're looking for the square root. If you have a 3, you're looking for the third. So this is a 3 here, so we're looking for the third or the cubic root. If you have a 4, fourth root, and so on and so on. What you also have to understand and learn is how to change this exponential form, because we do have an exponent, into radical form. There's the radical. So this is how you set it up. You guys will take the base. So notice here's the base. So for example, the 8, there's the 8. My roots is on the bottom, so the root is going to go outside of the radical, in between the tail and the radical. So we have the third root, there's the 3. And the exponent is going to be how much you're going to raise that to that power. So in this case, we have a square, so you're going to raise this to the second power, squared. So this is how you set it up. And notice we do have parentheses in between the radical and the exponent. Or you guys can write it as this as well. And this is just another way, which is also correct. You guys will have the roots outside, so there's the n, outside of the radical. But the exponent is inside of the radical. Notice here it's outside and it's outside the parentheses. But here we have the exponent inside of the radical. So if you guys want to simplify this right here, well, we are looking for the third root of 8, and whatever that is, we're going to raise it to the second power. So the way you set it up, you have the third root of 8 squared. The third root of 8, well, you're looking for the number that you multiply by itself 3 times, and that's going to be 2 times 2 times 2, that is 3 times. 2 times 2 times 2 is 8. So the third root of 8 is 2. And then you raise that number to the second power. So we have the second power up here. 2 squared is 4. So when you look at 8 to the 2/3 power, well, the answer is 4. The third root of 8 is 2, and 2 squared is 4. So let's go ahead and practice and changing a exponential form into a radical form. And then I'll show you guys how to use a calculator to actually simplify those. So we have some examples here. First, let's go ahead and change those to radical form, and then we're going to simplify while using a calculator. So notice the first two are exponential form because the exponent is a fraction. There's the exponent. The next two are radical form. So we have the 8th root here, and we have the 3rd root over here. And the last one, well, you guys have a fraction with an exponent of 4/3. So let's go ahead and see how to change this one into a radical form. We want to change it with the radical. So first, let's see what the exponent is. So the exponent here, you guys have a 2/3. So the bottom number is your root. So we are looking for the third root of 64. And the top number is your power. We want to know, after we know what the third root of 64 is, we're going to raise that to the second power. How do you write it in radical form? Well, I start with the third root like this. I have the 64, the base becomes the radical and it goes inside the radical. And then with parentheses, I put the exponent outside. Now, you guys can also put the exponent inside of the radical, but I'm used to using parentheses with the exponent outside. The next one, same thing. Before I show you guys with the calculator, the next one, you guys have 256 to the 5/4 power, or 5/4 power. So first, let's go ahead and start with the roots. So my roots is 4. So we're looking for the 4th root. And I am looking for the power of 5. I'm going to raise that to the 5th power. So how do you write that down as a radical? Well, first, you put the 4th root right here. You put the base inside of the radical, so now it's the radicand, 256. And then you guys will use parentheses here, and the exponent is 5. So after we find what this is, we can raise that to the power of 5. Okay, so let me show you guys with the calculator. Alright guys, so to show you the calculator, I am using one that is called Desmos, and that's an actual application. And you guys can go to desmos.com, www.desmos.com, and I am using the scientific calculator. They also have a graphing calculator that you can use, which is the same thing as the one I'm going to show you here, but this is not with the graphing part, just a scientific calculator. So Desmos is a very good app that you guys can use, and you can download it in your cell phones, tablets, and it is free. But let's go ahead and understand how to use the scientific calculator so you can simplify this expression here. And notice that these two look very different because one is exponential form, the other one is radical form. But I feel it's a lot easier to use this form, exponential form, in a scientific calculator. So you can put this in the calculator and it's going to give you guys the actual answer. So let's go ahead and see how to use that in the calculator. So first you have to know what your calculator looks like. And in this scientific calculator, I notice that I do have a square. I have a button for my exponent. We have a as a base and b as the exponent. I have a fraction, and we do have a fraction here, so I'm going to have to use this one. With the radicals, notice we do have a square root here, and we have the nth root right here. If we have the third root, this is what we use. Fourth root, this is what we use. So this very good idea that you always know how to use the calculator that you have, and every brand is different. There's a lot of brands out there, so just look at how to learn how to use the calculator. So let's go ahead and try it. I'm going to have 64, so I'm going to put it in the calculator, 64 here. I'm going to need a exponent, and I'm going to make my exponent a fraction, and I put 2 over 3, and decimals gives you the answer on the right side. So the answer is 16. So my answer for this one here is just 16. 64 to the 2/3 power is 16. When in reality, you're asking the third root of 64 squared. All right, let's try another one. And the next one is the number different. We have 256 to the 5/4 power. So once again, I'm just going to use the calculator here. 256. Let me clear everything here. 256. We have the exponent and make that a fraction, 5 over 4. And your answer is 1024. 1024. All right, so let me put the calculator on the side here. But we are going to continue here. And the next two, we want to change those into exponential form. So what that means is you want to have an exponent as a fraction. So we need to understand what we have. We have the 8th root here. We have the exponent of 3, and the base, or the radicand, is 256. So the way you guys will write it is you start with the radicand, which is going to become your base, 256. I have my fraction here, and my root is 8, so that's going to go on the bottom of the fraction. And let me just put root here. And my exponent is 3, because that's inside of the radical as an exponent. So the power is 3. So using the calculator, you can simplify this right here. And I'm just going to use scientific calculator again. And the answer is 8. I already did it in the actual calculator. So my answer is 8 for this one here. And just notice how I put it in the calculator, just like you see it in exponential form, 256 to the 3/8 power. So let's try this one here. You guys have the third roots, and your radicand is 125. So you put the 125 here. My fraction will be the exponent. My root is the 3 right here. And my exponent is 4, which is right here. And then you guys do that in the calculator, and you guys find the answer. Now this is, before I tell you guys what the answer is, this right here is your exponential form, and this one up here is called your radical form, because you do have a radical. But let's find out what the answer is. And the answer is 625. Okay, so the next one is when you guys have a fraction and you guys want to change that to radical form, and then we're going to use it using the scientific calculator to find what the answer is. So we are asking 8 over 125 fifth power to the 4 over 3 power. So my radical form, first of all, remember we start with the radical. The denominator is going to be your roots, so that's going to go outside of the radical. I'm going to write the fraction inside of the radical, so 8 over 125. And my exponents will be 4. So I'm going to put 4. So from exponential form, we went to radical form. And using the calculator again, notice that I have my expression here inside parentheses. Every time you guys do see parentheses in your expression, make sure you guys use those in the calculator. So we have 8 over 125, and the exponent is 4 over 3. Now, this scientific calculator gives you a decimal form, but you guys need to convert that into a fraction. So this expression here is a decimal. We're going to change that to a fraction form. If your teacher asks you guys for decimals, well, you guys are fine. You guys can use the decimals. But usually, when we find radical or square roots, we leave that as fractions. So this expression right here as a fraction is 16 over 625. So we have the fraction here. And remember that every calculator is a little bit different. So make sure you guys know how to use that calculator, where you guys need to press for the exponent, the fraction, the radical, and so forth. If you guys want to use a square root or the cube root, usually your scientific calculators that you have two different buttons, one for the regular square root and another one for a different root. So make sure you guys look into that. So let's go ahead and look at the next concept. The next concept is right here. You guys do have to solve exponential equations. So notice what I have here. I do have an equality, the property of equality that is called the power property. And when you guys have an x as an exponent, so look at this expression here. You guys do have x as an exponent, your base is 5. We can use this property to solve for x. So let me explain what it is. If you guys have an expression 5 to the x power, so the x is an exponent, equals 5 to the third power. Well, to find the x value, if the bases are the same on each side, so there's base of 5 here, base of 5 over here, you can cross those out. And once you cross those out, you don't need to use them. All you have to do is keep the exponent. So I do have an x and a 3, so I'm going to put x equals 3. So my solution, my answer is x equals 3. But the catch is you guys need to have the same base on each side of the equation so you guys can cancel the bases. This is an exponential equation. It's not the regular linear equation you guys learned previously, but this is just a little bit different. Now, when you guys have a number next to the x, so notice the next one here, if 2 to the x plus 4 equals 2 to the 10th, well, if the bases are the same, the 2 and the 2 are the bases, you can cross those out, and we're going to keep the bases. We do have x plus 4 and a 10. So I'm going to have the equation x plus 4 equals 10. So in other words, you just put that on the left side, the exponent, and the other one on the right side. So x plus 4 equals 10. We can actually solve for x on this one. And this is going back to a linear equation, the regular one you guys learned at the beginning of the class, of the school year. You guys do the opposite, you add, subtract, you divide, or maybe you multiply. But here, you subtract 4 because you do the opposite of the 4, the constant, subtract 4 over here, so your answer will be x equals 6. But the idea for today, when you have an exponential equation, you guys need to have the same base on each side. How do I know it's an exponential equation? Look at the x. The x is an exponent right here. Okay, 2 to the x power. Do not get confused. This is not 2x plus 4. The x is an actual exponent. So the way you have to look at it is 2 to the x plus 4. So notice the difference. This one is 2x. You're just multiplying 2 times x. But this one you have 2 with the exponent of x plus 4. So don't get confused with those two expressions. We do have an exponential equation. So let's try a few examples here. And notice the examples, they do not have the same base on each side. So what I mean is you have a base of 6 over here, 216 over here, so they're not the same number. At base of 3 here, there's the x as an exponent. 27 is not the same number. 8, 512, and 4, 1024 are not the same base. They're not the same number. So when that happens, we can still use the property I showed you guys, but we need to change the numbers so we can have the same base. So let's look at the first one here. When you guys have a base, in this case is 6, let me bring down the equal sign here. Well, you guys will keep that base. There's the base of 6. and there's the x. But on this side right here, I need to convert or represent that number 216 with the base of 6 and an exponent that is the same value. What do I mean? What I mean is 6 to what power is going to be 216. And this is where you guys use a calculator. You try to find out an exponent. You try 6 squared, well, that's 36. And then you try 6 to the third power. And let's find out what that is. And that is 216, 6 to the third power. And once again, guys, you use the calculator to check. So I'm going to put a 3 right here. 6 to the third power is 216. So now look at the bases. They're equal. So once they're equal, you can cross the bases out. And you keep the exponents. You bring down the x equals, and you bring down the 3. X is by itself, so we don't have to solve for, it's already solved for x. So my answer is x equals 3. That's how you solve. The next one, same thing. You guys have a base of 3, so I'm going to make this one a base of 3 with some exponent. So let me bring down the 3 first here. There's the exponent of x. And right here, 27. Well, I know 3 to the third power is 27. That's how I know that 3 to the third, 3 times 3 times 3 is 27. And once the bases are equal, we'll cross those out. They're gone. So you bring down the x equals, and you bring down the 3. So my answer again is x equals 3. Don't think that it's always 3. This is just how it works. But you guys can have any number, x equals 5, x equals 2. You just have to look for that base on each side to be the same so you can cancel. Now let's try the next one here. So next one, I do have a base of 8. So I'm going to keep my base of 8 here. There's the exponent of 3x, so x is an exponent. And I need to change that number, 512. So I need a base of 8 to some power that gives me 512. So I'm going to check with the calculator. 8 squared is 64. Nope. 8 cubed. So let me try that. In the calculator, yep, it is 512. So 8 cubed is 512. So you try to look for that exponent that's going to equal the number that you guys have at the beginning of the equation. Once you guys have the same basis, cross those out. You bring down the 3x. Notice x is not by itself. It has a 3 next to it. And then you bring down the 3 on the other side. This 3, you bring it down. And this 3x, you bring it down. So now you guys are going to solve. So to solve for x, you divide by 3. And this is going back to a regular linear equation. You just want x by itself. So you do the opposite. And you divide here. So this turns into 1. And we have the x equals 3 divided by 3 is 1. So my answer, x equals 1. Now the last one, you guys have a bigger number. And notice the x has more things next to it. So 4 to the 2x plus 1. So we have a 2 and a 1 here. And then we have 1024. So first, let's keep the base. So there's the base of 4. I'm going to keep my exponent 2x plus 1 here. And on the other side, right here, I need to change that to base of 4 to some power that gives me 1024. So let's check with the calculator. I check 4 squared. Nope, that's 16. 4 cubed, that's 64. And I found out 4 to the 5th power is 1024. Using a scientific calculator, you just put 4 to the 5th power and it gives you 1024. So 1024 is represented as an exponential form, 4 to the 5th power. Now that we have the same basis, once again, the 4 is the base, the 4 is the base, you can cross those out. So they're gone, and you guys bring down the exponent. So we have a 2x plus 1 here equals a 5 over here. Now you start solving like a regular linear equation. Subtract 1 from both sides. That's gone. So we have 2x equals 4. You guys divide by 2 on each side. This turns into 1. So x equals, and let me just move this up so you guys can see, 2. So my answer for this one, x equals 2. All right, guys, this concludes my video, my second video for section 7.3. Make sure you guys check out the first part. Also, make sure you guys practice and I'll see you guys later.